6th grade, Module 5, Lesson 9, Classwork. Example 1. Jasjeet has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area to know how much fencing and dirt to purchase. Determine both the perimeter and the area. Alright, so remember perimeter, we haven't worked with perimeter in a while, but perimeter is just the length around the outside. So the distance around the outside. So let's start by finding the perimeter of this. Let's start with FE is, the distance is 1, 2, 3, 4, 5, 6, 7, 8. DE is 1, 2, 3, 4, 5, 6. CD is 1, 2, 3, 4. CB is 1, 2, 3, 4, 5, 6, 7. AB is 4. And AF would be 7 plus 6, so it's 13. So what we can do is add all of those together. So to find the perimeter, I'm going to do 4 units plus 7 plus 4 plus 6 plus 8 plus 13. And add all of those together. I'm just going to add these, so that'd be 11 plus 4 plus 6 is 10 plus 8 plus 13 would be 21. And if I add 21 plus 21, we get 42 units. So the perimeter is 42 units. Now if I wanted to find the area, what I would do, I'm going to break it into, use a different color. Let's break it into 2 rectangles here. So I'm going to have rectangle A and rectangle B. So for area, I have rectangle A and rectangle B. So to find the area of rectangle A, base times height, it's 7 by 4. Would be equal to 28 units squared. And then rectangle B is 8 by 6, which would be equal to 48 units squared. And if I want to know the total of those two together, I'm going to add them together. So 28 plus 48 is equal to 2 plus 4 is 6, plus 1 is 7, so 76 units squared. Example 2. Calculate the area of the polygon using 2 different methods. Write 2 expressions to represent the 2 methods and compare the structure of the expressions. Okay, so we have to solve it 2 different ways. So I'm going to start by breaking up the interior of the triangle. And there's a lot of ways to do this. There's not one right or wrong way to do this. But I'm going to draw a line across there so I can create a right triangle there, a right triangle there with, so we have A, B, C, D, E, and F. So I have 6 different shapes here. Again, you can break it up differently. This is just how I chose to do it. So I'm going to find the area of, let's call this method 1. Okay, so we have shape A, shape B, shape C, shape D, shape E, and shape F. So we're going to find all of those and add them all together, and that'll give us the area of that whole hexagon. So A, if we're looking at it, the distance, the height is 1, 2, 3, and the width is 2. So 1/2, 3 times 2, half of 6 is 3 units squared. Shape B is a rectangle, so it is 4 by 3. So that is 12 units squared. Shape C is also 3 by 2. So 1/2, 3 times 2 would be equal to 3 units squared. Shape D over here is also 3 by 2. And it's a rectangle, so we take half. Shape E is another rectangle, 4 by 3. And shape F is 3 by 2. 1/2, 3 by 2 would be equal to 3 units squared. Okay, so what we can do is add all of those together. So let's do, I have 1, 2, 3, 4 threes. So 3 plus 3 plus 3 plus 3, and then 2 12s. So these threes are equal to 12. So we basically have 12 plus 12 plus 12, or 12 times 3 is 36. So the area of this is 36 units squared. And if we were to write an expression, it's going to be long. Let's write our expression. We're just going to take all of this and add them all together. So we would have, I'll start down here because it's going to be long. Ready? 1/2, 3 times 2 plus 4 times 3 plus 1/2, 3 times 2 plus 1/2, 3 times 2 plus 4 times 3 plus another 1/2, 3 by 2. So there is an expression. So for the second method, what I'm going to do is, let me get rid of what was in there. I'm going to find the area of the outside. I'm going to make a rectangle around the outside. And I'm going to find the area of these red pieces. And I'm going to find the area of the rectangle, find the area of the red pieces. They're easy to find the area of because they're all right triangles. And then I'm going to subtract them from the area of the rectangle, and I'll be left with the hexagon. So method 2, let's call this shape 1, shape 2, shape 3, shape 4. So shape 1, shape 2, shape 3, and shape 4. And the rectangle. So the rectangle, let's start with that. It is 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6. So the rectangle is 48 units squared. Let's see, shape 1 is this one up here. It's 1, 2, 3 by 1, 2. So half 3 by 2, because it's a rectangle, would be 3 units squared. Shape 2 is also 3 by 2. I think they're all going to be 3 by 2. So 1/2, 3 by 2. Shape 3 is also 1/2, 3 by 2. Shape 4 is 1/2, 3 by 2. So if I take my 48 units and then I add, or when I'm going to subtract all of the shape 1, 2, 3, and 4 out. So 48 minus 3 minus 3 minus 3 minus 3, or 48 minus 12 would give me 36 units squared. So the area of that is 36 units squared, which is good because that's what we got over here as well. So our equation, what we did is we found the area of the rectangle, 8 times 6, and then we subtracted all of these out to find what was left, or what was the the hexagon. 1/2, 3 times 2, minus 1/2, 3 times 2, minus 1/2, 3 times 2, minus 1/2, 3 times 2. So there is our expression. So then it says, how do these expressions differ? Well, they're just two completely different methods. So the first expressions shows these terms being added together because we're finding the area of the inside of the hexagon. We're using the hexagon to find the area of it. And on the other expression, we found the area of the rectangle on the outside and then subtracted the extra end triangles so that we were just left with the hexagon. So we had to take away the extra pieces on that method. So two different ways to get to the same answer. Hopefully you just find one that works for you and stick with it. Okay, number 1, determine the area of the following shapes. All right, so I'm going to, I think it'd be less pieces since it has 1, 2, 3, 4, 5, 6. I think it has 8 sides. We have an octagon, so I'm going to use the rectangle method here. I'm going to find the area of the rectangle and then subtract these right triangles on the outside. So the area of the rectangle is the height is 1, 2, 3, 4, 5, 6, 7, 8, 9 by the width is 1, 2, goes all the way across, so it's 10. So 9 by 10. So the rectangle is 90 units squared. So let's take out these corner pieces here. So we have 1, 2, 3, 4. So let's do shape 1, shape 2, shape 3, shape 4. So 1 is 3 by 3. So 1/2, 3 by 3. Or 1/2 of 9 would be equal to 4.5 units squared. Shape 2 is also 3 by 3. Let's see, are they all 3 by 3? It's 3 by 3. Yeah, they're all 3 by 3. So we're just going to do that 3 more times. Okay, so we need to do the 90 units minus whatever these all add up to. So 4.5 plus 4.5 plus 4.5 plus 4.5. 4.5 plus 4.5 is 9. So we get 9 plus 9 is 18. So we're going to take the 90 units squared and subtract out the corner pieces, the 18, and we'll be left with the center octagon. So we get 72 units squared. And B. So for B, we have this shape. So there's different strategies you can take. You can break it up, which, I'm going to go with the square method again because it's going to give me a bunch of right triangles, and I can easily find the area of right triangles. Okay, so let's find the area of the rectangle. It might be a square. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 8. So the whole rectangle is 64 units squared. Or square. Square is a rectangle, so we can call it a rectangle. So let's do shape 1, 2, 3, and 4. So shape 1, the height is 4 and the length is 3. So 1/2, 4 times 3, or half of 12, is 6 units squared. Shape 2 is also 3 by 1, 2, 3, 4. Oh, maybe 5. 1, 2, 3, 4, 5. Yep, 3 by 5. Or half of 15 would be 7.5. Shape 3 is 1, 2, 3 by 1, 2, 3, 4, 5. So half of 15 again. And then shape 4 is 1, 2, 3, 4 by 1, 2, 3. 6 units squared. Okay, so let's add the 6 plus 7.5 plus 6 plus 7.5. So the 6 plus 6 gets me 12, and 7.5 plus 7.5 is 15. 12 plus 15 is 27. So all of these outside triangles add up to 27 units squared. And I just need to take that out of the whole rectangle. 64 minus 27. We get 37 units squared. That would be the area of the polygon on the inside. Number 2, determine the area and perimeter of the following shapes. So we're back to finding the perimeter as well. Okay, so let's start with perimeter. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This side is 4. This is also 4. 6, 6, and 10. So to find the perimeter, I'm going to add all of those units together. 10 plus 6 plus 6 plus 4 plus 4 plus 10. So I'm going to add the 10s together. So we have 20 plus the 6s would be 12 plus the 4s would be 8. And then I get 20 plus 20 is equal to 40 units. So the perimeter is 40 units. And the area, I'm going to split it. There's different ways to split it. I'm going to break it like that. So we have rectangle A and rectangle B. So the area of A is 10 by 6, or 60 units squared. The area of B is 4 by 4, or 16 units squared. If we were to add those together, we get 76 units squared as the area. All right, B. Looks like we have a big T here. So let's find the perimeter first. I'm going to start with this side right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 4. This one's also 10 because it's congruent and parallel to that side. This is 4. This is 6, which means this side's also 6. See, this side right here is 1, 2, 3, 4, 5, 6, 7. And then this up top here, you could count it, or we could add 7, 4, and 4 together. That would be 15. So let's add all of those units together. So we'd have 6 plus 15 plus 6 plus 4 plus 10 plus 4 plus 10 plus 7. I'm going to just add them in groups. So 6 plus 15 would be 21. 6 plus 4 would be 10. Plus 10 plus 4 is 14. Plus 17. So we have 21 plus 10 is 31. And 14 plus 17. I don't want to make a mistake here, so I'm just going to... It's 31. So we get 31 plus 31 is 62 units. So the perimeter is 62 units. So let's find the area. So we can do that by breaking it into, I'm just going to do 2 rectangles. So we have rectangle A up here, rectangle B down here. So the area of A, let's see, it's 15 by 6. And 15 times 6 is 90. The area of rectangle B would be 10 by 4, or 40 units squared. If we add those together, 90 plus 40 is 130 units squared. Is the final area there. And that is the end of the classwork.